Welcome. This video is for IGCSE Physics Paper 4 0625 Practice Paper 2 for the upcoming examinations. Now a U-shape, though this is monometer is not been there, then also we are trying to do it out so that it may be useful for the next part of the question which is there in the syllabus. Now a U-shaped of constant cross-sectional area contains a water of density. This is a density given which is rho. Both sides of YouTube are open to the atmosphere. So over here I have atmospheric pressure. Over here I have atmospheric pressure over here. So both are same. So that is the reason they are of same level. Now the atmospheric pressure has been given as 1 times 10 to the power of 5 pascals. The left side of the tube is now connected to a gas supply. Now we are connecting to a gas supply over here. So obviously because of the pressure of the gas, it comes down. How much ever it comes down by 0.200 meters. It goes up by the same 0.200 meters. So now the total height is going to be nothing but what? 0.400 meters. Calculate the pressure of the gas supply. Give your answer in three significant figures. So we can clearly see that the pressure of the gas is greater than pressure of the atmosphere. Therefore, it is coming down. It is pushed down. So now I need to know the pressure of the gas. So pressure of the gas is nothing but what at that time pressure of the atmosphere plus pressure of because of that liquid. Now pressure of the atmosphere was 1 times 0 times 10 to the power of 5 pascals plus pressure of the liquid is nothing but what rho gh. I use a formula rho gh. What was the density given? 1000. And what is the acceleration due to gravity? I take it as 10. Then height I take it as 0.400. So which gives me nothing but what? 1.04 times 10 to the power of 5 pascals. 1.04 times 10 to the power of 5 pascals is going to be the pressure. Now figure 3.3 shows that the gas supply is now connected to a cylinder. So there are particles and now it is connected to a cylinder. So the gas is pushing it this side, whereas the atmosphere is pushing in this direction, opposite direction. The pressure of the gas moves the piston to the right. Why? Because we know that the pressure of the gas is more than pressure of the atmosphere. Therefore, it goes finally, the movement is going to be the opposite direction, which is nothing but what? Towards the right. Next, the area of the piston is given as 0.025 meters square. Calculate the resultant force. So resultant force is pressure equals to nothing but what? Force upon area. So force is nothing but what? Pressure times area. But I want resultant force. Resultant force is going to be nothing but what? Resultant pressure times area. So what will be the resultant pressure? Which is pressure of the gas or air minus atmospheric pressure times area. So which one was 1.04 times 10 power 5 minus 1 times 10 to the power of 5 times area. Area is 0.025. Simplify that by the calculator. You should be able to get that answer as 100 newtons. That is going to be the force. Don't forget to write the units. Next, what is that? Next part of the question. The pressure of the gas causes the piston to move a distance of 0.5 meters to the right. Calculate the work done by the gas to this one. So we know that work equals to force times distance. What was the force? Because this is by the gas, so we have to take it out. Pressure of the gas, not the resultant, times area gives me the force. So in order to calculate the force, which is nothing but what? Pressure times area, I will be using pressure of the gas because I'm finding it out work of the done by the gas times the distance. So what is the pressure of the gas? 1.04 times 10 to the power of 5 times area is 0.025 times the distance is 0.5. Simplify that, you should be able to get 1300 joules. That's coming to question number 1. Coming to question number 2. A radiation detector is placed on the bench in a laboratory. It detects background count rate of 40 counts. The background count is 40 counts per minute. Why this is? What is the meaning of background radiation? It is a radiation that is always present. that is always present in the environment. That is called as background radiation. And suggest one source of it. One source of it can be either be soil, you can write any one of the thing, or you can write sun, or you can write either rocks. Any one is sufficient enough. A sample containing an atoms of a radioactive isotope polonium is removed from a lead container and brought close to the detector. Now it is brought close to the detector. The average count increases to 10. Basically it was 40. Now counts per minute. Now it is increasing to 890 counts per minute. When two sheets of paper are inserted between the sample and the detector, when I inserting two sheets of paper, now the average count again comes down to 40. Means that radiation from the polonium is not being getting what is this passed through. It is not able to pass through. So what is that is radiation from polonium is not passing through the sheets. So what kind of radiations we have? Alpha, beta, gamma. So we know that alpha has the least kind of radiation. So which kind of radiation it can be? Alpha can be the emission. So alpha emission. It can be an alpha emission as they have least penetrating power. Penetrating power. So that's going to be the alpha emission because it is coming back to 40. So alpha emission is the least one. Write down the nuclear equation for the decay of the polonium. So 208 polonium 84. So we know that 2He4 is coming out. So balance it out. 208 plus minus 4 is nothing but what? 204. 84 minus 2 is nothing but what? 82. So it has to be lead. That's going to be the answer. Coming to question number 3, take the Hooke's law. What does this Hooke's law states? Extension of a spring. Extension of a spring is directly proportional to, so remember you should be using the word extension. Extension of a spring is directly proportional to the load. Till where? Until elastic limit. Until elastic limit. Then you'll be getting the full 1 mark. Now on 2.1, mark the label of the region where it obeys the Hooke's law. So for that, what am I going to do? I'm going to draw a straight line. Once I draw a straight line, see that till where it is straight. It is straight till this point and it starts turning over there. So that's going to be the, what is this, turning point. Now calculate the spring constants. We know that F equals to Kx. So K equal to F upon X. So it is load divided by the extension. So we take randomly from any one point. For example, I take randomly from 15. 15, then hit the graph. So when I'm hitting at 15, it is hitting the graph over there. So let me draw once again. So from 15, I'm taking it, hitting the graph over there. Then from there, I draw it out over here. So it will be something approximately 107.5. So therefore, extension is 107.5. So what is that now? It becomes 15 divided by 107.5, which is 0.16 Newton per millimeter. The original length of the spring is 120 millimeters. Calculate the length of the spring when the, what it says, load is 8.5. So what am I going to do from 8.5? Where is 8.5? Now this gap. How many lines gap is nothing but what? It is 20 lines gap. 20 lines gap is 10. So each two lines is 1. 1, 2, 4. Then if at all it does becomes like that. So this is 5. Now between 5 to 10. 5 to 10, the gap is 5, and how many parts are there? 10. So each part is going to be 0.5, means two lines is 1. So this is 6, this is 7, this is 6, this is 7, and this is 8, and this is 9. So 8.5 is over here. So from 8.5, draw the line and hit the graph and bring it over here. So this is going to be nothing but what? 60. 60 mm. So the lower extension is nothing but what? 60 mm. So original length is what? 120 mm, but the extension is what? 60 mm. So going to be the answer 180 mm is going to be the answer. Now coming to the next part C. The weight of the object is 4 newtons on a planet when the acceleration is 8.7. Find the mass. So weight equals to nothing but what? 4 newtons. Then acceleration equals to 8.7 meters per second square. Mass equals to question mark. So W equals to mg. So m equals to W by G. W is 4 by G is 8.7. Simplify by the calculator. You should be getting 0.46 kgs. Question number 4. This shows a collision at a slow speed between two cars traveling along a straight line. Car B has a mass of 800 kgs. So let this be M1. M1 equals to 800. Then, and is moving with a speed of 2 meters per second. So U1 equals to 2. Car A and collides with the car A, mass 2 is 1000 kgs, which is at stationary. So U2 equals to 0. After the collision, both the cars travel in the same direction in the initial direction of the B. So after the collision, car A moves with 1.1. So car A. So V2 equals to 1.3. So what is going to be V1? So now this is collision. This is what? Momentum. Law of conservation of momentum. So momentum before collision should be equals to momentum after collision. M1U1 plus M2U2 equals to M1V1 plus M2V2. So this is 800 times 2 plus 1000 times 0 equals to 800 times V1 plus 1000 times 1.3. This gives me 1600 equals to 800 V1 plus 1300. So 300 equals to 800 V1. So V1 equals to 300 by 800, which when I do it out to one decimal, it is 0.4 meters per second. That's what being asked us to prove. Next, calculate the impulse. Impulse is nothing but what? Change in momentum. Impulse is change in momentum. So which is 1300 minus 0, which is 1300 Newton second. Next, state the impulse exerted by B on A. It's going to be the same. Reaction equals to or action equals to reaction or reaction equal to action. So same is going to be the momentum. Whatever A is on B will be same as B on A. Question number 5. A force is a vector quantity. State the two features of a vector quantity. What are the two features of a vector quantity? It has magnitude and direction. State the names of two other quantities that are vectors. Maybe we can write it as displacement and acceleration. Displacement and acceleration. Now, a student suspends a spring from a clamp and measures the initial length L0. A student then suspends the loads of different weights from the spring and measures the length of the spring for each load. He then plots a graph for the spring. Point 2.2 is the graph that student plots. Determine the initial length. So, what's going to be the initial length? Initial length is when load is 0. What is this one? This value whenever the load is 0. So, how much is the gap? Gap is 0.2 and there are 10 parts. So each one is going to be nothing but what? 0.02. Each one is 0.02. So now this is 0.02. So 2, 4, 6, 8, 10, 12. So 0.12. It's going to be 0.12. So once again, this is 0.02, then 0.04, 0.06, 0.08, 0.10, and 0.12. So the initial length is going to be nothing but what? 0.12. And don't forget to write the units. So what are the units over here? Meters. State what is meant by the limit of proportionality. Limit of proportionality at this is a point. It is a point. It is point. It is the point. It is a point beyond where extension is not directly proportional. directly proportional to the weight. Now he's asking what is the weight, and what is going to be the weight he's asking at which. So now we see that wherever the limit of proportionality is ending, so wherever it's not a straight line, so I'm drawing a straight line and then check. It is not becoming a straight line over here at this point. So drop it down again. So this is going to be 10.6. So 10.6 newtons. Using figure 2.2, determine the spring constant. So force equals to kx, k equals to force upon x. So force was, what was the force? We can take force at randomly any one point. So I'm going to take the force at maybe at 8 newtons. I draw over here at 8, hit the graph and bring it out over here. It may be 0.4446. It is 0.46. So force I take it as 8 and the extension is 0.46 minus the initial length, because x is the extension. So but the length was 0.46 and the initial length is nothing but what is 0.12. So it becomes 8 divided by 0.34, which is going to be 24 Newton per meter. Question number 6. A quantity of gas is trapped by a piston in a cylinder with thin metal. The piston is free to move without the friction when within the cylinder. Then the atmospheric pressure is given, the area is given. Calculate the force. So we know that force equals to pressure times area. Pressure is 1.0 times 10 to the power of 5 pascals times area 2.4 times 10 to the power of minus 3, when it becomes 240. Again, newtons. When the cylinder is first placed into the freezer, the temperature of the gas in the cylinder decreases and air pushes the cylinder. Calculate the work done. Work done is nothing but what? Force times distance. What was the force? Force was just now we calculated 240, and what was the distance it is moving? 0.021. It's going to be nothing but how much? 5.0 joules. The initial temperature was 21 and the final it decreases to minus 18, and the thermal capacity is this much, change in the internal energy. So the formula is going to be E equals to C delta T. C is nothing but what? 89. Delta T is change in the temperature. Final minus initial. So minus of minus 18. So K should be taken over there. Minus of minus 18. So 89 times 39, which becomes 3471. But you should write always in three significant figures. And don't forget to write the units, 3500 joules. When the temperature reaches minus 18, the pressure of the gas in the cylinder is still equal to that of the atmosphere. Oh, when the temperature reaches, the pressure in the cylinder is the pressure of the gas is still equal to that of the atmosphere. Explain in terms of the particles how pressure remains equal. Why pressure is remaining equal? So what's happening is now the temperature is decreasing. Temperature is decreasing. If the temperature is decreasing, particles will collide less frequently. Less frequently. Less frequently. So therefore, what will happen to the pressure? Pressure also decreases. Pressure decreases. Now next time, the volume also is decreasing. When the volume of decreasing, collision will increase because of the less space. Collision increases. Collision increases, what will happen to the pressure? Pressure increases. Pressure increases. But we can see that on one hand the pressure is increasing and on the other hand the pressure is decreasing. So they balance out. So they balance. So that's why what it says, there is no change in the, there is no change in pressure. As the temperature of the metal cylinder decreases, the volume of the metal decreases. The decrease in the volume of the metal is much less than the decrease in the volume of the gas. Explain in terms of the particles of the metal why decrease in the volume of the metal is less than that of the gas. Because what's happening in the solid is the molecules are very close to each other, and the attractive force is larger than that of the gas. So therefore, and also the particles are closer to each other. when compared to that of the gas. So therefore, the volume will be decreasing much more lesser when compared to gas. So what I can write in solid, attractive force is larger than gas, and also the particles are closer together, and also the particles are closer together in solid than gas. That is the reason. Question number 7. Tidal power derives most of its energy from the moon and parts of its energy from the sun. State one other source of power which derives the energy from the sun. So maybe wind energy or solar energy. State one source of power which does not derive energy from the sun. Geothermal energy. 3.1 shows small water turbine driven by a tidal flow. Explain whether this method of generation is electrical power is renewable or not. Yes, it is renewable. Why it is renewable? Because tides are unlimited. It will never end. Then the mass of the water passing through a turbine is this much. The speed of the water is given, and 40% of the kinetic energy is converted to electrical energy. Find the electrical power. So first of all, I'll have to find it out the kinetic energy. What is the formula for kinetic energy? Half mv square, which is half times mass is 6 times 10 to the power of 3, and v is nothing but what, 2 square. This gives you 12,000 joules. But I want power. So power equals to energy divided by time. Energy was 12,000 and time is 1 second. So which is nothing but 12,000 watt. But again, it is only 40%. So an efficiency will be 12,000 times 40 upon 100, which is going to be 4,800 watts because power is in watt. Question number 8. Figure 5.1 shows an aluminium block after leaving a furnace in a factory. The mass of the block is 1200 kgs and it is heated from 20 to 380. Specific heat capacity. What is the thermal energy gained? Just now we have done E equals to mc delta T. M is 1200 times C is 960 times 380 minus 20. Do that 4.15 times 10 to the power of 8 joules. Figure 5.1 shows a factory worker standing at 3 meters away from the block. State and explain the main purpose by which the thermal energy is transferred to the worker. It is transferred by the infrared because there is no contact. So we can write it as it is done by infrared radiation. Infrared radiation travel to him and absorbed by him. State and explain the main purpose by which thermal energy is transferred from the outer surface of the solid metal rollers to the interior. So the interior, outer surface to the interior, it is just done by conduction. Simple thing is, it is done by conduction and lattice vibration, which is also done by lattice vibration because 3 marks, right? You cannot write only 1 point. So 3 points should be taken. And also by free moving electrons. Free moving electrons between molecules. Question number 9. An aeroplane accelerates along the horizontal runway before takeoff. The aeroplane accelerates for 35 seconds. The speed of the aeroplane when its takeoff is, this is initial speed, 72. This shows the speed of an aeroplane varies from t0 to 35. Define acceleration. What is the definition of the acceleration? Rate of change of velocity. Simple definition, rate of change of velocity. Calculate the average acceleration. Acceleration equals to v minus u by t. V is 72 minus 0 by 35, which is going to be 2.1 meters per second square. The combined mass of the aeroplane and the passengers is this one. Calculate the average resultant force. So we know that force equals to ma. The mass is 1.1 times 10 to the power of 5. Acceleration just now we got 2.1 meter per second square. So it's going to be 2.3 times 10 to the power of 5 newtons. The force provided by the engines of the aeroplanes is constant. Give one possible explanation for the change in the acceleration of the aeroplane between t0 to t35. Why there is a change in the acceleration though the force is constant? Because we know that as speed increases, the air resistance increases, the air resistance air resistance increases. That is the reason it should be accelerating. Now, sketch the graph on how the acceleration of the aircraft varies between T0 to T35. So first of all, for this part, it is constant acceleration, straight line. Then it is decreasing acceleration. For the next part, it is decreasing acceleration. And again, it becomes a straight line, constant acceleration. So first part, it was a constant acceleration. Then it decreases. Then again, it becomes a constant acceleration. So this is going to be the way of drawing the graph for that. So that completes question number 9. Now we are left over with 3 more questions. Question number 10 also we can complete now. So this is tennis ball hits the racket with a speed of 52 meters per second. The average force during the time that is in contact with the racket is 350 and leaves the racket with 26. So it is hitting with plus 52, going back with minus 26. So remember that you should change the symbols. Calculate the change in the momentum. So m times v minus u. So what is that? 350. What was the mass? Change in the momentum of the ball. What was the mass of the ball? Mass of the ball is 0.058. Convert grams into kgs times minus 26 minus 52. So it becomes minus. So when I do by the calculator, its value is going to be nothing but how much? 0.058 times minus 26 minus 52. So which is going to be giving me minus 4.5. Don't worry about the negative symbol, just write it out 4.5. And momentum is nothing but kg meter per second. Next, state the equation which defines the impulse. Force, what is this? Impulse equals to force times time. Calculate the time of the racket it is in contact with the ball. So what is that? Time equals to impulse by the force. Impulse is 4.5 and the force is nothing but what? 350. Simplify that 0.013 seconds. Difference between the values of the kinetic energy before and after the impact of the racket. So half mv square minus half mu square. So half times m is 0.58 whole times 52 square minus 26 square. Simplify that, you should be getting it out 59 joules. That's going to be the answer. That completes question number 10. Coming to question number 11. A girl holds a rubber ball out of a window of a tall building. The mass of the ball is 0.20 kgs. The ball is at a rest of 10 meters above the concrete path. Calculate the gravitational potential energy. MGH. M is 0.2, 9.8 and 10. It's going to be 19.6 joules, but you should write in two significant figures, 20 joules. The girl releases the ball and it falls towards the path. The ball strikes the path and bounces upwards. Calculate the kinetic energy of the ball immediately after it strikes the concrete path. When it strikes the concrete path, its velocity is 12 meters per second. So half times 0.2 times 12 square. So which is 14.6 joules. So therefore, which is going to be 14 joules. Show that the change in the momentum of the ball when it bounces to the path is 5.2 kgs per second. So mv minus mu. Then 0.2 times minus 12, then minus 0.2 times, what was that one? It is going to be 14. So which is going to be minus 5.2 kg meter per second. So no need to write the symbols. So just only minus 5.2. So we can write it as just only 5.2 over there. So I copied down the answer over there. Now coming to the last part, the ball is in contact for the path for 0.25 seconds. Calculate the average resultant force. So for that, force equals to m times v minus u by t. So So I am substituting the values, which is minus 12 minus 14 divided by 0.25, which is going to be minus 20.8. So then I'm going to not going to write it as 20.8 newtons, because you should be writing in on two significant figures, 21 newtons. That's going to be the answer. Now, question number 12. A radio transmitter is very tall, thin cylinder. Then it is prevented from falling over the wires, which have one fixed end to the transmitter and other end fixed to the ground. The ends of the wire and the ground are long distance from the transmitter. Find the center of the gravity. The center of the gravity is shown in this figure. State what is the meaning of the center of the gravity. What is that? It is a point. It is a point where all weight acts. Explain why the radio transmitter without the wires is very unstable. Because the center of gravity should be always perpendicular to the base. If at all there is a slight twist, what it says, it will fall off. So therefore, what am I going to write it out? Center of gravity, COG means center of gravity. What is this? Will be no longer vertically above the base if there is a small tilt. That is why it should be supported by the wires. Then wire W is under tension and it exerts a force T. On 4.1, mark an arrow with force T and on this one. So what am I going to do? I am going to mark an arrow T, and this is a force F, and this is a vertical distance D. Next, last part, the radio describe how the moment of produced by T is calculated and indicate on 4.1 what is it meant by in other terms in the description. So its moment is calculated by force times perpendicular distance. That is a formula. The radio transmitter uses the radio waves to transmit radio and television programs. State one another use. Another use can be astronomy. So that completes this paper. See you in the next paper. Bye.